Welcome to this lecture series on PERT and CPM. So in this lecture, we are going to discuss about CPM. What is CPM? CPM stands for Critical Path Method. Now, what is PERT? PERT stands for Project Evaluation and Review Technique. In project management, three phases are available. The first phase is planning. So what do you mean by planning? Take an example. This is an image of house construction. Here you can see that various stages of house construction. Digging the earth, rising the foundation, rising the pillar, rising the walls, and finally constructing the roof, then interior decoration, and final house is constructed. So you can see that various activities are involved in the construction of houses. So these activities we have to plan it. What is the estimation for each activity? What are the other resources it will consume? Say for example, what is the cost involved in that? What are the materials we are going to use? What are the manpower we are going to use? So these resources we have to do an estimation. When we can start an activity, which activity is depending on other activity. So like that we have to decide in the planning stage. For example, we cannot put a roof concrete before completing all these activities. So the interdependency of the activities we have to decide during this stage. The next stage in the project management is scheduling. Once we decide about time estimation, we have to decide to start which activity at what time. So here we have to decide about starting time and ending time of an activity. So this is what you mean by scheduling. So the scheduling gives an order of activities. The third important point in project management is controlling. We have to see that whether the project, whatever we have planned, while executing, it is according to the plan. So we have to see that in the execution phase, we have to see whether according to our plan, everything is carried over. Suppose if there is a delay due to some unexpected reason, then we can revise the schedule and then again the plan can be carried over. This is what you mean by controlling. So in CPM and PERT, these tools are used by project manager in order to schedule the activities of the project. The first step in CPM and PERT is construction of a network diagram. The network diagram tells you the logical flow of activities. Two important points are to be noted in network diagram. First one is called as activity. So here you can see that the activity is represented by an arrow joining two circles, and this is the activity A. For example, in an house construction project, this could be laying the foundation. So an activity is nothing but a portion of the project. Diagrammatically, it is represented by an arrow mark joining two circles, where this is the starting point of the activity and this is the end point of the activity. Another term what we are going to use in CPM or PET in the network diagram construction is event. Event is similar to what we have already mentioned in the activity. So these circles are called as events. That is, events are nothing but the starting point and ending point of the activity. This event by themselves does not consume any resources. It just mentions when an activity begins and when an activity ends. We give name tail event for the beginning of the activity and we give the name head event for the end of the activity. Let us take an example now, how to construct a network diagram. Suppose take a house construction project. So here the list of activities are given: preparing the housing plan, constructing the house, fixing the door, wiring the house, painting the house, polish the doors. You can see that for all these activities, just for convenience, we are giving some alphabets A, B, C, D, E, F. And when we can begin an activity and when we can end it, to find out the starting and finishing event, we just give numbers. So in network diagram, every activity is identified by the number. So we are giving the numbers like this, 1 to 2, 2 to 3, like that. For every activity, we have to find out what are the predecessor activity, meaning that we cannot start an activity without completing another activity. So that activity is called as a predecessor activity. And we have to give an estimation of time, how much time it will take to complete an activity. So here in this example, if you look at the first activity, preparing the housing plan is the starting point of the project. So it doesn't require any predecessor. If we look at the second activity, construction the house, we have to complete the housing plan. So the predecessor is A for this. And it is also identified with the numbers. So these numbers again we'll see in the diagram. Again, if we look at fixing the door, we have to complete the construction of the house. For wiring the house also, we have to complete the construction of the house. So after the construction of the house, fixing the door and wiring the house can start simultaneously. And for painting the house, we have to see that the door and windows should be already fixed. And similarly, to polish the door, the wiring the house should be completed already. So the predecessor activities are identified here. With the help of this, we have to construct the network diagram. Let us draw the network diagram for this example. So for reference, I have copied the same image here. So the activities are A to F. So the first activity is prepare the house plan. You can see here there is no predecessor for it. That means that is the starting of the project itself. So the activity A is drawn with event number 1, which is the starting point of the activity A, and it ends with event 2. So I am joining 1 and 2 with an arrow and indicated by activity A. So now to draw activity B, construct the house. The predecessor is A, that is house plan should be completed before constructing the house. So the starting point for activity B is 2 and end point I am using a circle with 3. So I am joining 2 to 3, which is called activity B. So now if you look at C, which is fixing the door or window, activity B should be completed. That is, construction of the house should be completed. So the starting point for activity C should be 3 and end point is 4. So I am drawing 3 to 4 and naming it as C. Again, if you look at the activity D, the predecessor is B. That is, construction of the house should be completed before wiring the house. So now I am drawing with starting point 3 and end point 5. 3 to 5 as activity D. You can see that for both the activities C and D, the predecessor is B. That means the activity C and activity D both can be started simultaneously after completing B. So now look at the activity E. It should be started after completing C. That is, starting point should be 4. So from 4, I am drawing 4 to 6 with activity E. Again, if you look at the activity F, polish the doors or windows, activity D should be completed. That is, D should be completed for starting F. So I am drawing 5 to 6 and I am naming it as F. So here you can see that the final event is 6. So the activities E and F merge at 6. So in a network diagram, the important point is there should be only one start event which is numbered as 1 and there should be only one end event which is numbered as 6. So this rule should be remembered. For the entire network, there should be one start event and one end event. Let us take another example to draw network diagram. Let us consider a housing project similar to the previous example. Here list of activities are given, predecessor is given. So now to draw the network, again I have copied this image just for reference. First I am going to draw the activity A. Activity A doesn't have predecessor. So the start event is 1 and the end event is 2. So I can draw A like this. So A, activity A starting from 1 ending with 2. Since there is no predecessor, I am starting with 1. So now look at B. B is also having no predecessor. So again I am starting with 1 and ending with 2 and I am naming it as B. Again I am going to draw C. In order to draw C, the predecessor is A. So A is the predecessor. So after completing A, then only I can draw C. So let me put a number 3 and I am drawing 2 to 3 as C. Again I have to draw D now. So to draw D, you can see that the predecessors are A and B. So let me draw D by using an event 4 like this. Now let us analyze this diagram. If you look at this diagram, for activity D, the predecessor should be A and B. So that is satisfied. So A and B are completed, then only we are starting D. But if you look at C, it indicates that A and B are completed and C is started. But what is the requirement? The requirement is for starting C, A alone should be completed. It doesn't talk about B. But the diagram says that both A and B should be completed to start C. So this is an error in the diagram. Why this error happens? Because the rule says that no two activities can begin and end at the same event. So here if you look at two activities are A and B. For both of them, the starting point is 1 as well as ending point is 2. So this should be avoided, which is an error in the network. So let us again redraw the network. So let us take the activity A. So I am drawing it as 1 to 2. And now I am going to draw activity B, which is 1 to 3. So you can see that I am using different events now. In the previous diagram, they are same events. Now it is different events. So now let me draw activity C. After completing A, I have to take C. So 2 to 4 I am drawing with activity C. Now let me draw activity D. So you can see that I am drawing after completing B, I am drawing D. But what is the requirement? The requirement says that both A and B should be completed in order to start D. But the diagram indicates that only B should be completed. So how to include A? So in order to include A, let us introduce a dummy activity. So a dummy activity is included like this. So now you can see that A is also completed, B is also completed in order to start D. So this 2 to 3 is called dummy activity. And this dummy activity does not consume any resources. It is just used to maintain logical flow in the diagram. Now let us draw E. So in order to draw E, I am using 4 to 6. This is activity E. Now again I can draw F by joining 5 to 6. So F is nothing but we have to start it after completing D. So all the requirements of the activities are satisfied in this diagram. So important point is we have to remember the use of dummy activity, which is used to maintain logical flow in the diagram. Thank you for your patience. In the next lecture, we will discuss about finding critical path.